Hello, everybody. Glad to see you. It's More Data, and there is a very important speaker for us. It is Vishnu, and Vishnu opened very important topics for data engineering. His previous talk was about costs in the cloud and how to reduce costs in the cloud, and now he will tell us about data quality. And data quality is a core thing in data, because if we have garbage in our data, we cannot use it no matter how many effort we spend on it, on cooking it and looking at it. Vishnu, great to see you. Hello.
Nice to meet you all. Nice to be here.
Vishnu, how did you move from spending costs in cloud to data quality? I think that it is a little different topics of the data. One about hard engineering, deep, and the second one is about data. It is about what we save in this data, about more topic of your business and analytics. How did you do this change?
So, as the presentation goes on, you will get to know that quality has a link with cost as well. The more the garbage, the more the dirty data, the more you run your data pipelines, and the more the cost actually increases silently behind. So, in a sense, they're kind of linked together. So, not a switch exactly.
Oh, it is very interesting. I cannot wait more. Let's start.
Sure. Hello, everybody. Thank you for attending my talk. I'm Vishnu. I'm from India and I'm currently based in Singapore. I'm the Chief Inspiration Officer at Bytespire.io. And currently I work for QZen, which is a healthcare AI based startup. So you must be aware of various fitness trackers like Apple Watch, Google Fitbit. In Singapore, we have a population of about 3 to 5 million people. So we collect data for those 3 to 5 million people and run it through our machine learning algorithms to provide personalized recommendations on how you can improve your health. So an example would be, today you walked 9,000 steps. So we send a recommendation saying, hey, do an extra 1,000. That would be really good for you, right? That's a simple recommendation which we give. So as you know, since we process a large amount of data, quality really matters, and that affects the recommendations which our AI engine actually gives. So that quality will be the focus of our talk today. So moving on, you must have heard about this very common quote from a friend or a colleague or a teammate that they don't have confidence in your data pipelines. So this particular talk will try to address those concerns. So here is a blog post from Monte Carlo's website, which talks about how Uber miscalculated the driver payments by a whopping $45 million. So I just wanted to stress upon you that data quality really matters, and if you ignore it, then it might have severe consequences later on. So just keep that in the back of your head. So as the title suggested, there was something about data angiograms. So let's focus on the word angiogram. An angiogram is a medical procedure which you can undergo to figure out blocks in your arteries. Why is this important? If there's a block in your artery, you can have a heart attack. So what they actually do is they insert a tube into you and insert a special dye into your bloodstream. Once the dye is inserted, it flows through your bloodstream. So then what they do is they actually do a special kind of X-ray and figure out, as you can see here, how the blood flows through your arteries. And that's because the dye actually illuminates the blood. So in this particular angiogram which you're seeing, on the upper left-hand corner, which is circled, there is a very narrow artery which restricts the blood flow. So this is an actual problem for a patient. He could be prone to heart attacks. And this is what an angiogram actually does. It helps you to figure out these blockages. So you might be wondering, what does a medical procedure like an angiogram have to do with us in the data world, especially the data engineering world? So think of the arteries as your data pipeline, the blood like your data, which flows through your data pipeline. That's how similar it is. And coming to the blockages in your artery, there are two types. The one on the left is a narrow artery where you have restricted blood flow, and the one on the right is a total block where you don't have any blood going through the artery. So both are severe cases of possible heart attack. So the one on the left is actually equal to something like your pipeline actually succeeding, but there might be issues with your data quality. And the one on the right, where there's a total block in the artery, you can think of it as one of the jobs in your pipeline has failed, and hence data flow has totally been interrupted. So that's how similar it is with regard to a data pipeline and arteries. So let me come to the definition of the word data angiogram. It's a special data set or a test data set, more specifically, which you create and inject into your pipeline. And then at each phase in your pipeline, you compare the expected and actual results. If the expected and actual results don't match, then there's something wrong with your pipeline. And that's what an angiogram is a data angiogram is in very simple terms. So as we go along, I'll show you how to build a data angiogram. So come to think of it, as I told you, they inject a special dye into your bloodstream in an angiogram. So if you think about it, this special dye is the special test data set which you are going to create and going to inject into your data pipeline. So since I mentioned about Uber's case where they miscalculated the driver payments by $45 million, excuse me. So let's take a simple taxi data pipeline where you have a taxi ride. The data comes in through an API. The API pushes the data to Kafka or any data stream out there. And there is a simple Airflow DAG which runs. The first job of the Airflow DAG is to pull the data from Kafka and store it to blob storage. Blob storage can be S3 or Azure blob storage or Google Cloud's blob storage, anything. The second job could be a simple report which you are calculating based on the taxi rides. For example, number of taxi rides which originated in the city of New York. That's a simple report, right? So let's take this simple data pipeline and move with this throughout the presentation for you to understand how we can build a data angiogram for this pipeline. So for the taxi data pipeline, on the left, we have a simple JSON, which is our input data schema. So since it's a taxi data pipeline, obviously we are talking about a taxi trip. We have attributes like taxi ID, passenger ID, start time, end time, pickup zip code, drop zip code, the tax amount, the fare amount, the currency of the transaction, and the car model. So the car model is something like whether he was going in a Toyota or a Mercedes Benz or a Ford, right? From this input data schema, what we intend to do is create a report, a simple report for the purposes of this presentation. We group by date, car model, and currency and give you the total revenue. That's a simple, even a real use case which we have these days. So we'll attempt to create this report, and that is what the pipeline is going to do. And while doing so, once the report is generated, we will run our data angiogram. I hope this is as it's clear. So let's talk about how we build a data angiogram. As I mentioned to you, the data angiogram is a test data set which we are going to prepare and inject into the pipeline. So first, we need to set up the pipeline, and you might have multiple pipelines running in your company. So the first thing is we need to set up the pipeline. So when we think of pipeline, we need an environment in which we need to run, right? So come to think of it, GitHub and GitLab are your traditional CI/CD environments, and they are a good environment to run the data angiogram because it's part of your CI/CD infrastructure. It would be a good choice. You could run it at a daily cadence or an hourly cadence. Daily is good so that it runs along with other CI/CD pipelines. With regard to tools for setting up the pipeline, Docker is a very good tool to use. For most of our infrastructure pieces, especially with regard to our pipeline over here, Kafka is available as a Docker, Postgres is available as a Docker, MySQL is available, Airflow is available as a Docker, right? If you're using Prefect is also available as a Docker container. And if you're adventurous and using Kubernetes in your real world pipeline, you have Minikube, which can also run as a Docker. So Docker is a very good tool to set up most infrastructure pieces. And anything related to your job in the pipeline, that could be packaged as a Docker image. And most of the workflows out there have their code in a Docker image. The next step, as I mentioned, is we inject the data into the pipeline and we compare the expected and actual results. So how does this comparison take place? So a simple way is to write tests, and you can use pytest or testng or JUnit depending on the language you like. The data angiogram is agnostic of what language you use to write the data test. For the purposes of this presentation, and since Python is generally popular, I'll be using pytest over here. Lastly, and very importantly, is some sort of notification mechanism. And I suggest you use Slack if you are using it, or you can use any other thing. The purpose of using a notification channel like Slack is to inform your team that the angiogram has failed or succeeded. So what we generally do is in our companies, we run the angiogram just before the stand-up. So when the stand-up starts, we have our results ready. If it has failed, it encourages a discussion as to why the angiogram has failed, what has gone wrong with the pipeline. So it's best and to run the angiogram just before your stand-up and get a Slack notification as soon as it completes. So that's about the environment and the pipeline which you need to set up, right? Coming to the most important part is preparing the data angiogram, which is preparing the test data set itself, right? So when I say prepare the test data set, first you need a test scenario. For you think of a particular test with regard to your pipeline, and you need to generate records for it. How to generate records? It's quite simple. You can do it manually. I hard code a record or ask ChatGPT to do it for you. It's quite simple to generate records. So for the purposes of this presentation, we will take a scenario. We'll generate 12 taxi rides such that there are 3 passenger IDs, Tom, Jerry, and Batman. There are 4 different car models like Toyota, Benz, Ford, and Jeep. There's one taxi ride where the start time is of the year 1970. So this is a case where we are trying to push very old data into the pipeline and see how the pipeline reacts. Then there's one taxi ride where the passenger ID is null. So this is another case of dirty data where we are going to introduce into the pipeline. Then there's one taxi ride where the billing amount and the tax amount is negative, which is also a case of dirty data, right? Then there are 2 valid taxi rides for Jeep, and the rest of the taxi rides are for Toyota, Benz, and Ford. So this is a very specific scenario which I have thought of, and you might have different scenarios to test. You can generate your test data records as per your scenario. So once you generate the data, the next step and most important step is to actually validate the test data which you have generated. What do I mean by that? So when you generate data, you need to have confidence in the data which you have generated. Because if the pipeline fails, you need to know that your data set is accurate and correct, and there's probably an issue with the pipeline, because your data is actually controlling the entire pipeline flow, right? So you need to write tests to validate the conditions as per your test scenario. So in this particular case, I would write tests to verify that there are 3 passenger IDs in my test data set. There's one taxi ride of 1970, the year 1970. There is one taxi ride with passenger ID null, so on and so forth. So the moment you validate your test data, you will have more confidence even before we actually perform the data angiogram. So with these 2 steps, one of setting up the pipeline, 2 preparation of your test data set, you're ready to actually perform the data angiogram. Mind you, step 1 is a one-time activity where you set up your pipeline. Step 2, which is preparing the test data set, will go on forever. The more test scenarios, the more test data sets you will have. So I wanted to actually give you a real demonstration. So let's switch from these slides to GitHub. So what you're actually seeing is a GitHub workflow which I have created called the Data Angiogram pipeline. It's a GitHub workflow with multiple steps which I've created. So I'll walk you through all the steps one by one. So the first step of the workflow, as you can see here, is GitHub's setup, whatever it does. The second one is generation of tokens, GitHub tokens, if you need to use it for certain purposes like checking out your code. Then the third one is checking out the actual repository, which is quite common, that you need to check out a certain code base. The fourth is setting up Python, because my code is running in Python 3.10. I might need to set up Python 3.10. You might need to set up JDK if you are running Spark jobs or something related to Java, or your API is in Java, like a Spring Boot app. So you can set up JDK. The next step, which I call is letting the Pythons into the garden, is actually doing, it actually means doing all your pip installs, all the dependencies which are required for your Python project. So that's letting the Pythons into the garden. Then you might need to log into your private Docker image registry, because every company will have its own private registry. So you might need to log in to that registry. The next step is pulling the Dockers images and recording the versions of each of these Docker images. So this is very important. As I mentioned earlier, Docker, you might have your code packaged as a Docker image. So we need to pull that as part of, so that we can run the pipeline. But what's more important is recording the versions or the tag versions of those images. Why is this important? If the pipeline fails tomorrow and succeeds today, you can actually come back to this step, compare the versions across the 2 workflows, and check which version of which component has changed. So that helps you boil down the culprit very fast by looking at what versions have been pulled. So this is a very important step. You need to record the versions of the various infra pieces you are using. Once you've pulled your Docker images, you can start your Docker containers. So here I am starting up all the containers which are necessary. There is Kafka. There is also, I think, there's Zookeeper, Kafka, which is required for this particular pipeline. Then I'm also starting up Airflow, because we are going to run a specific Airflow DAG, right? So all these Docker containers are starting up. There's Postgres. You might have a different DB. You can start it up, right? So as part of the startup of the Docker containers, that is for the infra. As part of our pipeline, as I mentioned, we have an API which is a specific code base as part of your pipeline, right? You need to start that Docker container as well. So that's also started inside of this step. Then we do a simple health check on Airflow to check if it is up by doing a simple curl. Then this is the first checkpoint to see if the API which you have started has actually started up or not, because your entire pipeline starts with the API, right? So this is the first checkpoint which I put over here. It's checking whether the API is up. In this case, yes, so it has succeeded. Now, this is the main part where we start to perform the angiogram. So the first step is generation of data, as I mentioned. The next is validate data. And the third step is send angiogram. So let me just break it down, the generation part. So the generate angiogram is a simple script which I've written here. The first step is Python generate data.py. So we are generating the data. The second is after generation of data, we run our pytest, and I'll walk you through those tests. So once this is done, we are now free to send the data to the pipeline. So the generate data is a very simple Python script which I have written based on my test scenario. You will have different test scenarios, so you can generate the data as per your convenience. You can hard code it, or you can, in my case, I've hard coded a few records over here. But you can generate random data, or you can ask ChatGPT. It's up to you. So this is a simple script to generate your data. The next script, as I mentioned, was a simple pytest, which I'm writing to validate the test data set. So as I mentioned, I was sending data of the year 1970, a very old record. So I've written a test to test the number of very old records. And I'm asserting that the count is 1. Assert 1 is equal to number of 1970 records. This is one test. I'm also sending null and non-null passenger IDs. So I've written a test to verify that I'm actually generating such data. And then I have a test for checking if I'm generating a record with a negative amount, a negative bill, fair amount and tax amount, and other tests for the various conditions I have on my test scenario. So this is my pytest. And when I run the first step of my generation and validation, I generate the data and run the tests. If this succeeds, the next step is to send the angiogram data. In my case, it's a simple curl command. So I just curl the API. So that's what I'm doing in the code here. So all this code is available in GitHub for you to look at later on. So you don't have to worry about the code. So this script I've written here is just to curl the API, right? So coming back to the GitHub workflow, as you can see, you will see multiple JSON records here. So these are the JSONs which have been generated. Then I'm running the test for the generated data. It seems to be succeeding 100%. Then I'm sending that via curl. So all of that seems to succeed. The status is success, payload has been ingested, which is good. So this is where our job kind of ends, where we generated the data, validated the test data, and sent the angiogram data. So our next step is a data consistency check. We actually check the number of records we have in our generated data and the number of records which have been ingested. So they need to match. So this is a very important data consistency check. If you generated 12 records, as in the example over here, you need to send 12 records successfully as well. So this is a simple data consistency check. Once it hits the API, if you remember, the API pushes it to Kafka. So we have another data consistency check, which I've added here, to read the number of records in Kafka. So we have a simple Python script which I've written to consume data from Kafka. And we compare the numbers. So in this case, number of messages expected is 12. and number of messages received is 12. So they are a match. So all good so far. We sent 12 records. 12 records have arrived in Kafka. So now we trigger the pipeline DAG. So this is an actual, there's a script to a simple curl command which you can run to trigger your DAG. So it's actually triggering the DAG, and the status is queued. That's the initial status of the DAG. And then it moves on to running and failed or success, right? So for the purposes of this demo, what I have done is I've just printed the final output of the report, which gets generated at the end of the DAG. So as you can see, you have car model, state, currency, trip date, and revenue. So what I've done, for example, Ford in the state of Nevada on 3rd September, the revenue was $6.17. You'll notice, for example, this particular record, Toyota, the state is null for some reason. We'll figure that out, why it is null. It could be a bug, right? But this seems to be a very fishy record that Toyota, there's a Toyota and the state is null. This should not be the case, right? So just do keep that in mind. This is a case of bad data quality coming up right now. But yeah, just for the purposes of this demo, I have printed the final output over here, you to see. So after that, we check if the DAG is a success. So we query Airflow and check the state is a success, all well and good, right? And after the DAG is successful, now we come to our final phase, which is our angiogram verification. Here we run a simple pytest where we compare the expected data and the actual data. So let me show you the pytest which I've written. So the first test which I wrote as part of the angiogram verification is a data completeness test. I'm verifying that the state column in the statistics is not null, which has to be the case. But if you noticed earlier, for Toyota, the state was null for a specific column. So in that particular case, this test case will fail. So this is a data completeness test. Then the second test is a data consistency test, which I've written to verify if all the car models are present. So if you remember, we ingested Toyota, Ford, Benz, and Jeep. There are 4 models. So I expect those 4 models to show up in my report. So this is a simple assertion that the count should be 4. The third test, which I've written, which is a data consistency test, I need to verify if old records are being considered or not, right? So which should not be the case. If you're sending something for 1970, it should not come into your pipeline at all. It should be stopped at a certain flow. So I have a certain assertion there. The last test which I wrote is a data accuracy test. This is an important test. We are going to verify the revenue for Jeep specifically, because we have sent 12 records. Some of those records are negative, have negative fare amount, negative tax amount. Some records have a null passenger ID. We need to verify if those records are impacting the final calculation of the revenue. So I've written an assertion here to verify. And this is a series of, as I mentioned, pytests. And depending on your scenario, you will write as many tests as you want to verify the final output. So these are my pytests over here. And when I ran this particular verification on the pytests, unfortunately, most of them are failing. So test verify state column is not null, is failing, because as you saw above, some of the state column was null for some records. Old data is being considered because 1970 is available in the day output. The revenue accuracy obviously will not match what I have written. It is also failing because it is considering the negative fair amount as well. So in this case, unfortunately, 3 test cases have failed. Only 1 has passed, and hence the angiogram has actually failed. And hopefully, not you will get a notification like this in Slack that your angiogram has failed. And if this comes before you stand up, it's a good talking point to figure out what has changed, why has it failed, what has broken. And one good thing is when it comes in Slack, just for the convenience of people, you can make sure that you have a link to the run. So when you click on view run, it will actually take you to that specific run for that particular day. You can click on it, figure out what has failed. So this becomes an easy debugging tool for you immediately for people to see what has failed, right? So that's pretty much it. Unfortunately, this angiogram is failing at the final checkpoint. Else you'll get a congratulations and you're good to go. So this is a simple GitHub workflow which I have built. If you're using GitLab, something similar will also come up in GitLab, right? As you can see, I'm using Airflow. So I'm actually running an actual DAG of somebody, right? So it's not a custom made thing. Any DAG can be added and you can run a particular thing. So coming back to the presentation, that was the demo which I showed you. The focus, I just wanted to summarize in some sense. The focus was on data consistency, data accuracy, and data completeness. As I mentioned, all that code is there in the Python scripts which I've written, right? So to summarize, this is a very simple way for you to test your sanity and quality of your data pipeline all in one go, and all as part of your CI/CD environment. Two, it's also cost effective. You're not purchasing a specific software to do your data quality tests. You're just using open source tools here, tools which you generally use to run the angiogram. So it's cost effective. Three, it's extensible and flexible in the sense that you can keep on adding more and more test scenarios, more and more test data you can inject into the same pipeline and verify multiple scenarios. So you set up the pipeline once and add more and more tests as you go along. It can also, with this, it can possibly catch breaking contracts within the various components of your pipeline, right? There's a possibility. For example, int becomes string in your data and it breaks the pipeline. So that can be caught here because you can think of it as an integration test case, which you're actually running, right, in simple terms. So I have 2 reminders for you. The first one is that we are focusing on data quality and not quantity. So this is not about performance testing or load testing. That is out of the ambit of a data angiogram. We are only focusing on quality. And for quality, you don't need thousands of records. You just need 100, or you need a few records to test quality, right? And the most important thing is in the data angiogram, it's the test data set which you create. That's the most important thing. It's not where you run the angiogram. You can run it in GitHub, GitLab, or you can even pump the same test data set into your staging environment or your QA environment. Right? Environment doesn't matter. What matters is you create your test data set and write the final verification as a test, pump your data through whatever environment you have, and compare the expected and actual results. That's what matters as part of the data angiogram. So this is a screenshot of our angiogram at QZen, which runs all our pipelines. I mean, all our components of a single pipeline which we have, the major one. It's a big GitHub workflow which runs every day. Here are some screenshots, the latest ones, dated August, where it has failed. We call our angiogram a harvester, in the sense that our angiogram is actually called a seed. We plant a seed and we try to harvest the crop at the end of the pipeline. So that's why it's called the harvester. It's just a cute name which we came up with. With this, we were able to figure out multiple issues. Some of the issues were related to time zone. Which is very important because we have customers running who want to run in their local time zone and not GMT. So there was a lot of time zone mismatch, leading to multiple records getting missed or filtered, right? Then there were cases where certain data had to be ignored, but it was not, and vice versa. And some fields were deleted in the API, resulting in data not coming through correctly. So these were some of the main issues which we found with our angiogram, and we continue to run it daily, and it continues to help us find multiple issues. So one last thing before I wind up is I wanted to share with you an advanced angiogram technique. Is you can actually perform this angiogram in production. Yeah, let me repeat that. You can perform this in production. So if you take the Uber or the taxi dataset pipeline, imagine it's running in production. What you can do is inject a fake or a virtual taxi ride through your production pipeline. Okay, and the data which you inject should have special values such that it doesn't clash with your regular production data set. Okay, so I'll give you an example. You could have taxi. I'm a Star Trek fan, so you could have taxi ID as Starship Enterprise, passenger ID as Optimus Prime from Transformers, because no passenger will have his name as Optimus Prime. Car model could be the Federation Starship Constitution class, which is kind of a special value. And you could pump this taxi ride through your production environment, maybe hourly or daily, it's up to you. If you pump it through your production pipeline, it should wind up in some report or the other, right? Because it's getting mixed with the other data, which is there in your production environment. If it doesn't end up in your reports, then it means that it's getting swallowed up or getting lost in the entire pipeline, and you have a problem, a big problem then. So this is quite useful in very complex environments. So I used to work for a company called Flipkart in India, which is, think about it as India's Amazon. It's India's biggest e-commerce company. We had massive data flows from website to it entering the system, going through multiple components. It was very complex. So an idea there was to inject a fake order and make it pass through the entire pipeline. If it doesn't show up at various places, it means that there is a big problem in the pipeline. So this is an advanced angiogram technique, and yeah, you do need to have the courage to run this in production. Just like a real angiogram in real life, it is a risky technique in the real world. So, but yeah, I just wanted to share this advanced idea with you. Some people do run it. Some people don't wish to. It's up to them. So with that, I would like to end my presentation with a quote from one of my friends at Cisco, who said, "Quality data means quality decision making." So yeah, thank you so much. And yeah, I will end my presentation here.
Vishnu, thank you very much. It was very interesting, and many of your ideas about making something like unit tests for data is my passion, and I tried to use it in my real job. But I faced with some problems. Maybe you can share something about your experience. The first one is about idea about writing tests for data engineers. They don't like it and don't want to do it. And what is about you who roll these tests in your company and your experience?
So my experience was mostly from um, the head of engineering, where they kept on coming back to us saying that, hey, something is not right. We are sending bad recommendations to people. Something is not right somewhere in the pipeline. Something is not adding up, right? So the only way to debug this is to actually try to get production data, run it through your pipeline, figure out step by step. Maybe there's a problem with your Spark SQL or your DBT SQL somewhere. Maybe you're grouping by the wrong way. The only way you could figure that out, and as a developer, as a responsible developer, you need to make sure that your code is tested. So I came up with the idea of just testing my components in isolation by just introducing 10 records and seeing how does it come out. So I just extended that concept to the entire company. I set up the entire thing for the company, all the components. It requires a little bit of time, I would say, because you need to know everything about the pipeline. Maybe you need to know your colleague's component, you need to know how to set it up, the configurations. It's a one-time activity, but it's well worth it. And my team and the leads, they actually sanctioned the idea because they really liked that, okay, on a daily basis we are testing our pipeline, and they're very happy when bugs come out, and I'm also very happy when bugs come out. Rather than deploying it to production silently, bad data is going out, it can really impact, especially in the data world where you have terabytes of data and all that. So that was my experience. But someone has to take the initiative to set up once. Writing tests, ChatGPT can do it for you.
Oh yeah, that sounds great, and it is really good. The second problem we faced up was we have very big and difficult pipeline, and it with a lot of joins of the data, and it is really hard to generate data at the beginning of the pipeline that will still be at the end of the pipeline. Understand, when you join, you miss some data, then you miss more data, and then you get zero data. And it is when you have a lot of inputs, then you can lose something. What about your experience with this problem?
So that's the beauty of this. Your job is to write the PyTest and hope it fails. In the sense that you generate, you just, so as you mentioned, you have joins of multiple data sets.
Yeah.
So for the person coming up with the angiogram, he will have to first prepare each of those data sets. And in this case, we're talking about quality of the join. So to be honest, I don't think you need a million records to verify if your join works or not. You just need to have a few records, and you need to prepare and think what sort of records will be there. So it could be as simple as 10 records in each data set for a specific test case. So a person has to just jot this down on paper, that these are my records, I'm going to run perform the join, and this should be my output. This is an offline activity which a developer can think, because he's the one writing the test case. So it's not about the number of records which are required here. Quality for most data engineering pipelines, especially joins, depends on maybe 10, 20 records, and your join will do its magic, right? So I think that is just a mental blocker, that you need a lot of records. You don't, right? If you're doing a group join, and group by, all you need is a few records for your join to work, right? So you write your data set, push it through the pipeline, write your pytest. If your pytest fails, well and good. That's all you need to do, right? And that's the objective, that, as you mentioned, 0 records are coming out. That's the objective of the angiogram, to catch that 0 records are coming out. Then you can raise a bug and then figure it out. One should not be worried about why the 0 records are coming. The person writing the test should just be worried about, okay, I need to catch that 0 records are getting generated.
Yeah, thank you very much. We have a question from Yuri. Do you run this test pipeline only on daily basis, or does it run automatically on every pull request? Maybe it can be as pre-commit checks.
We run it daily, just before the stand-up, and we pull the latest builds of each of the various components. You could run it on a pre-commit as well. It's up to you. But we make sure that we run it before our stand-up. That is most important, which is at least once a day.
Okay, thank you. And the second question from Yuri: why you use different infrastructure, and why you don't use some another control stable and run it separate from your production? And it may be faster than run all these things in Docker and spend a lot of time in GitHub.
So to answer that, we are GitHub is just the environment, and for us as a startup, we might not have the luxury of getting another environment in our cloud. So GitHub is a very easy place to run this sort of angiogram. It has a UI and it's quite readable. And GitHub is internally again running Docker. So for us, it's just convenient that our code base is in GitHub. Our everything, the CI or other CI/CD is running in GitHub. So this is also running in GitHub.
Okay, it is something about reusing your experience of development on the new thing, like this tool was your Angiogram tool. Your developers know how to use GitLab and or GitHub, and so they know how to use Angiogram. Okay, that sounds great. Hey, let's go to the discussion room. We are out of time, and everybody can ask questions to Vishnu. And let's say thank you for Vishnu for this great talk. It is very interesting and it is very important, because data quality, yes, it is a great word. Data quality means quality decision making.
Thank you.